Hi, this is Mrs. Stanley. Let's talk about solving for triangle sides with algebra. So we're looking at different types of triangles and information about them to solve algebraic expressions. You know that even though this is geometry class, we've always got to bring in algebra because algebra is the foundation of how we do everything. So if triangle ABC is an equilateral triangle, solve for both x and y. What do we know about equilateral triangles? Equilateral triangles means that the sides are all the same, right? So what can we do with this information? Over here, they told us this one is 49. So that means all of these equal 49. And they want me to find x and y. So this isn't actually too difficult of a problem. I can do 3x plus 1 equals 49. And I can do 18y minus 41 equals 49. So the fact that they gave me the 49 made this problem not too difficult because now I just need to solve for x and y. So solving for x, I have 3x plus 1 equals 49. So if I subtract 1, 3x equals 48. Divide by 3, and what do we get? 16. That's done. Coming over to y, 18y minus 41 equals 49. So this time I'm going to add 41 because it was a minus 41. So I'm adding 41 to the opposite side on the right. 49 plus 41 is 90, and on the left I'm left with 18y. And then I just need to divide by 18, and so I get that y equals 5. 5 times 18 is 90, and those are my two answers, and I am done. Okay? I found x and y. Let's go to the next problem and see if we should do that one together. Number 2, if triangle RST is an equilateral triangle, find x and the measure of each side. So what's going to happen here? Once I find x, I need to know the length of the sides of the triangles, right? So I feel like you can do this one because it's just like the first one, except we have to do one more step. Once you find x, you've got to find the value or the length of each side of the triangle. You can do it. I believe you. I believe in you. Number 3, MNP is an equilateral triangle. Find x and the measure of each side. That's exactly like number 2. Now, I guess what I'll show you, I'll get you started on number 2. How about that? So if all the sides are equal from an equilateral triangle, you could pick any two that you want and set them equal to each other. So it's your choice. If I do, for example, 12x minus 22 equals 7x plus 18, I then need to get the x's on one side and the constants on another. So I could subtract 7x and add 22. Switching the sides around. 12 minus 7 is 5x. What's 18 plus 22? It's 40, because 8 plus 2 is 10, and 2 plus 1 is 3, plus the 1 we carry is 40. So x equals 8. And then all I have to do is notice the sides. This is RS. And it is 12x minus 22. So I can plug in my 8, and I get 12x minus 22. Well, 12 times 8 is, what, 96? Minus 22 is 74. And then the next one I could do like ST. ST equals 10 times 8 minus 6. Well, that one's pretty easy because 10 times 8 is 80 minus 6 is 74. And then the last one is RT, and we get 7 times 8 plus 18. Well, what's 7 times 8? 56 plus 18, 74. Notice that they're all equal. They should have been because it's an equilateral triangle. If you get different answers for those three sides, then you know you did something wrong. You're going to do the same thing on number 3. Looking at number 4, this time it's an isosceles triangle. What does isosceles mean? Two sides are equal. How do you know which two sides are equal? Well, first of all, you can kind of tell by looking at the triangle. This side is going to be equal to this side. And we'll learn more rules about it later and how it can be marked. But this is the first piece of information, is just look carefully at the diagram and you should be able to tell. If it told you it's isosceles, you know two of them are equal. So you can identify which two. But it does tell you right here, DE is congruent to EF. DE, EF. You do want to look for what they told you, because what if they make a problem where they're purposely trying to trick you? We all know it happens. So look for the information that they told you, but also kind of eyeball it, and hopefully it makes sense. Most of the time it will. Find x and the measure of each side. So what do we know here? It's not much different than the the equilateral triangles we were doing. We just don't have to choose which sides. If DE equals EF, or if line segment DE is congruent to line segment EF, we just need to set these two equal to each other, right? These two are equal, find x, find the measure of the side. Same thing on number 5. And so the reason I'm skipping down is because you're about to see that the next side of the paper is going to get harder, and you're going to be like, oh, why didn't she do examples on this side of the paper? So I am. On number 6, PQR is an equilateral triangle, and look, they told you the 3 sides without giving you a diagram. You're still doing the same thing. It's the same problem, the same type of problem. You just have to either draw the triangle yourself to label it out, or use the information in the word problem very carefully, okay? So you're drawing a triangle, PQR. It's equilateral, so try to make it look equilateral, even though mine's not very good, but it's not a big deal. They told you it's equilateral, so we already know that, so we can mark it, and now it's proven that it's equilateral. And then label the sides if you need to keep it in order, okay? And just follow the same thing that you did back here on numbers 2 and 3, okay? Then we jump down to number 7, and suddenly this one is a little bit more difficult. Triangle STU is an equilateral triangle. If ST is 1 less than twice x. Okay, so now you're going to have to write the algebra. ST is means the equal sign, 1 less than twice x. So let's say that x is 8. What would be 1 less than twice x? You would do twice of x. 2 times 8 is 16, minus 1 is 15, right? You wouldn't do like 1 minus 8 is 7 and then double it. It's 1 less than twice x, so that's 2x minus 1. Way back in like 4th grade, maybe 3rd grade, you learned about turnaround words in word problems. Less than is a turnaround phrase. You switch the order. Sorry, I marked my arrow to the wrong thing. You switch the order. Instead of 2x being last, like 1 minus 2x, you switch the order and it's 2x minus 1, okay? So SU is 37 less than 5 times x. I meant to write the letters here. SU, again, less than. These are turnaround phrases. 37 less than 5 times x. 37 less than 5 times x. So I've got 5x minus 37. If you have to say it a bunch of times like I did, that's okay. TU is 11 more than x. Now, more than could technically be a turnaround phrase, but since it's addition, think about it. I'm just going to write over here, x plus 11 and 11 plus x are the same thing. That's why it doesn't really matter, but we could just be consistent and put the x first. And now we know the sides of the triangle. We know it's an equilateral triangle. And so we can draw the triangle, we can find x, and we can find the measure of each side, right? Coming down to number 8, it's an isosceles triangle with MK congruent to ML. So this time it does matter. I have an isosceles triangle. That means 2 sides are clearly congruent. Notice the MK and ML. That means they share a point M, which means M has to be up here. And then it would be like KL. How do I know that? Because if these 2 sides are congruent, the point that they share has to be the vertex. Okay? Because these 2 sides are equal to each other. And then they gave us the measurements for each side, and now you know what to do. Once you've drawn the triangle, this one is pretty straightforward. You just need to label each side and then find x using the fact that MK and ML are congruent, and then measure of each side. Number 9, triangle ABC is an isosceles triangle with AB congruent to BC. This time I'm still going to let you figure out how to set it up so that you can try on your own, and then finish out the problem, check your work, and see how far you get to finding x and the measure of each side. You will be able to do it. So we already know that. Number 10. What's the last one? GHI, triangle GHI is an isosceles triangle with GI congruent to HI. If GH is 3 more than X, HI is 17 less than 4. Pay attention to your turnabout phrases. 17 less than 4 times X, and GI is 45 less than 6 times X. Find X and the measure of each side. So I'm going to let you also try this one on your own, because if you don't do it on your own, it won't get any better. And that's the end of this video. But don't forget, you do have the answer key to use as a reference. It's not like you're just on your own to finish this. Use the answer key as a tool. Thank you.